Hi guys, myself Sadashiva MR. I am currently been studying in Sri Venkateshwara College of Engineering, Department of CSE Uh, Let us discuss today's subject about microcontroller and embedded systems. Topics to be discussed: microprocessor, microcontroller, specifications of microprocessor and microcontroller, various models of microprocessors and microcontrollers, applications of microprocessor and microcontrollers, and comparison between them. Let us first discuss about the microprocessors. Microprocessors is a central processing unit of CPU, computer, or electronic devices that performs an arithmetic, logical, and control operations. It is the brain of computer systems and is responsible for executing instructions, manipulating data, and controlling the overall functioning of the system. Microprocessors are found in wide range of devices from computers and smartphones to household applications, automotive systems, and instruction equipments. Key characteristics and features of microprocessors include processing power. Microprocessors are designed to process vast amount of data quickly and efficiently. They are execute millions of instructions per second or even billions of instructions per second in modern high performance processors. Instruction set architecture. The instruction set architecture defines the set of instructions that the microprocessors can execute. These instructions are basic operations that the processors understand, such as arithmetic operations like addition, subtraction, logical operations like and or data and movement like load, store, and control flow, branching and jumping. Registers. Microprocessors have small fast storage locations called registers, which holds data temporarily during processing. Registers are used to store operands, intermediate result, and control informations, speeding up data access compared to accessing the main memory. Clock speed. The clock speed of the microprocessors refers to number of cycles it can execute per second. It is measured in hertz and it is crucial factor in determining the processor's performance. Higher clock speeds generally means the faster processing, but other architectural factors also influence overall performances. Cache memory. Microprocessors often have built-in cache memory that stores frequently accessed data and instructions closer to the CPU. Cache memory helps in reducing the time it takes to access data from main memory. Means comparatively, the memory from the main memory is slower than the cache memory. Cache memory is speeder than main memory, enhancing overall system performances. It increases the system performances also. Pipelining. Many modern microprocessors uses pipelining, a technique that divides instructions execution into several stages. This allows multiple instructions to be in various stages of execution simultaneously at a time, increasing throughput and improving the performances also. Parallel processing. Some microprocessors supports parallel processing, where the multiple tasks are executed simultaneously using the multiple cores or threads. Uh, this features allows for better multitasking and improves the performance in multi-threaded applications. Power management. With the increasing emphasis on energy efficiency, modern microprocessors often incorporate power management features to optimize power consumption based on the workload and demand, enabling longer battery life in portable devices. Various models of microprocessors: Intel Core processor, AMD Ryzen processors, ARM Cortex A series processors, Apple A series processors, MediaTek Dimensity. NVIDIA Tegra processors, microchip PIC processors, Atmel AVR microcontroller. We can have a look into an images of different micro processors. Applications of the microprocessors. We can use in computers, smartphones and tablets, embedded systems, consumer electronics, and Internet of Things, IoT devices, automotive systems, networking equipments, medical devices, aerospace and defense, gaming consoles, robotics, data storages and servers, security systems, instrumentation and measurement, audio and video processing. Microcontrollers. A microcontroller is a compact integrated circuit or chip that combines various components of computer systems into a single package. It is essentially a uh, miniaturized computer on a cell as a central processing unit in computers and performs general purpose computer tasking. Microcontrollers are designed for specific embedded systems applications and are tailored to execute a tasks, specific set of tasks. Key features and components of a microcontroller includes Central Processing Unit (CPU). The CPU is a core of microcontroller responsible for executing instructions and processing data. Memory. Microcontrollers have built-in memory, which includes both read-only memory and random access memory, ROM and RAM. ROM, read-only memory, stores the program or firmware that controls the microcontroller's operation, while RAM is used for temporarily data storage during runtime. ROM is an permanent storage memory, and RAM is an used for temporary storage of memory. Input and output ports. Microcontrollers have an multiple input pins that allows them to interface with an external devices such as sensors, actuators, displays, and communication modules. This input ports enables the microcontrollers to interact with the external environment. Timers and counters. Microcontrollers have often includes hardware timers and counters, allowing them to generate presets that time delays, measures time intervals, or count events. Analog to digital converters. Some microcontrollers have a built-in analog to digital converters, allowing them to convert analog signals from sensors into digital data that microcontrollers can process. Uh, Serial communication interface. Microcontrollers supports various serial communication protocols such as UART, UART, SPI, 12C, and CAN, enabling data exchange with other devices. Clock circuitry. A clock circuit provides the necessary timing signal for the microcontroller operation. Various microcontrollers. PIC, micro, PIC microcontrollers, AVR microcontrollers, STM32 microcontrollers, uh, microcontrollers, ESP 8266 and ESP32 microcontrollers, ARM Cortex M microcontrollers, Intel Quark microcontrollers, MSP 430 microcontrollers, Geolog Z8 and Z80 microcontrollers. PIC microcontrollers manufactured by Microchip Technology. PIC peripheral interface controller. Microcontrollers are widely used in various applications due to their low cost, simplicity and easy to use. They are commonly used to consumer electronics, industrial automations, and die projects. AVR microcontrollers, developed by Atomel Corporation, new part of microchip technology. AVR microcontrollers are popular for their efficiency, low power consumption, and rich set of features. They are commonly used in Arduino boards and many day electronics projects. STM32 microcontrollers, manufactured by ST Microelectronics. STM32 microcontrollers are based on ARM context M series cores. They are commonly used in industrial applications, consumer electronics, and IoT devices. Arduino microcontrollers. These boards are based on various microcontrollers models, primarily from the AVR family. It has gained popularly in the making and prototype communication due to its ease of use and extensive libraries. Microcontrollers are widely used in various embedded systems and electronic devices, includes home automations, controlling lights, thermostats, and applications in smart homes, automotive systems, in engine control units, airbag systems, ABS, etc. Industrial automations, in processors control the monitoring system, robots, etc. Consumer electronics, in remote control smartwatches, watching washing machines, micro ovens, etc. IoT device. Uh, in connected devices, we are able variable variable guardages and sensor nodes. Wearable guardages and sensor nodes. Medical devices. In medical instruments, uh, medical patient monitoring and implantable devices. Security systems. In access control systems, alarm systems, and surveillance cameras. Educational tools. In development boards like Arduino, etc. Embedded systems in applications. Microcontrollers are used in various household applications like refrigerators, air conditioners, and smart TVs. Environment monitoring. Microcontrollers are used in weather stations, pollution monitoring systems, and environmental data loggers. Traffic control systems. Microcontrollers are employed in traffic lights, control systems, and tool booth systems. Now let us see comparison between microprocessor and microcontrollers. Microprocessors and microcontrollers. Uh, Microprocessor and microcontroller. From microcontroller. My, Microprocessor, a component that performs the instructions and task involved in a computer processing. A compact now microcontroller, a compact integrated circuit designed for a specific operations in an embedded systems, used for applications that required intensively processing. Microcontroller, used for an application that performs a particular tasks. Microprocessors, memory and input ports, timers, etc. are connected to the CPU externally. Microcontroller, CPU and all other elements are integrated into a single chip or a board. Microprocessor, microprocessor based applications performs multiple tasks. Therefore, it requires more memory comparatively to an microcontroller performs a single task. Therefore, it does not requires more memory in an input port, comparatively and compared to an microprocessor. Microprocessor has a high clock speed. Microcontroller has an low clock speed. Microprocessors uses USB UARTs and high-speed Ethernet as peripheral interface. Microcontrollers uses an 12C UART and SPI for the peripheral interfaces. Microprocessors consumes more power compared to a microcontroller. Microcontrollers consumes an less power. Microprocessors are costs more. Microcontrollers costs less. Microprocessors are large. Microcontrollers are small. Um, Microprocessors used by the person. Microprocessors are used in personal computers and laptops. Microcontrollers are used in micro ovens, washing machines, etc.